What kind of function is the most common function on the SAT and the ACT? A linear function, of course. A line is a function that increases or decreases at a constant rate, or slope. We see these over and over again in word problems, but today we are going to focus on ones that deal specifically with the XY coordinate plane. We're going to talk today about slopes, intercepts, and coordinate points. Get your pencils, get your paper. It's time to get that perfect score. Welcome to Perfect Score with Carl Rosenthal, your source for SAT and ACT math preparation. The math cats have the week off, but still stay, if for nothing else, your favorite nerd math teacher. Linear functions. We learn about these using what's called slope-intercept form, or y equals mx plus b. Let's talk about what these terms mean. So x and y are your variables, and they can stand in for any point on a line, any coordinate point where x is the x value and y is the y value. But what about m and b? These are called constants in that they're not variables, they can't change. What do they represent? Well, m represents what's called the slope, also known as the constant rate of change. And b is what's known as the y-intercept. In other words, whenever x equals 0, the y value will be whatever b is. Let's review how you find the slope when given 2 points on the same line. You may have learned that slope is determined by figuring out the ratio of the rise to the run. In other words, the rise over the run of a line. But what do rise and run mean? Let's say you have an actual line. Let's draw something right here. And let's say it looks kind of like this. Doesn't actually matter exactly where it is. If we pick any 2 points on this line, let's say we have this one and we have this one, and we first determine the rise. In other words, the change in the y values, the vertical change. That's represented right here. We can call that the rise, or the change in y. And we figure out the run, or the horizontal distance between the 2 points, otherwise known as the change in x. Your slope, or your m, is going to be the change in y over the change in x. Another method you may have learned to find slope is using something called the slope formula. The slope is always going to be y2 minus y1 over x2 minus x1. In other words, the difference between the y values over the difference between the x values. Pretty much the same thing as delta y over delta x, or rise over run. If I gave you 2 points on a line, 2, 1, and -4, 5, could you find the slope of the line that connects these 2 points? Why don't you pause the video and see if you can do it. Go. Okay, just to check your answer, let's plug in these points into the slope formula. y2, let's pick 5. That's the y value of the second point. Minus y1, let's pick 1, the y value of the first point. Over x2, so the x value of the second point, -4, minus x1, the x value of the first point. 5 minus 1 equals 4, and -4 minus 2 equals -6. This becomes 4 over -6. When we reduce, this becomes -2/3. -2/3 is the answer to that question. So I've selected 2 problems that deal with slope and linear functions. One simple, one kind of hard. Let's dig in. This one right here is number 5 from an SAT section 3. That means no calculator. Let's read. In the XY plane, line L passes through the points 0, 1 and 1, 4. Which of the following is an equation of line L? Let's go ahead and find that slope using that slope formula, where slope equals y2 minus y1 over x2 minus x1. Let's assign y1 and 2 and x1 and 2 to these numbers. Well, this point we'll call x1 and y1, and this point we'll call x2 and y2. y2 is 4, y1 is 1, x2 is 1, x1 is 0. 4 minus 1 over 1 minus 0 equals 3 over 1, or 3. Our m in our y equals mx plus b function, or our slope, is 3. Let's go ahead and cross off the options that don't have 3 as the slope. Clearly not A, which says the slope is 1/3, and clearly not B, which also says the slope is 1/3. C and D do have the slope as 3. Now, what is the y-intercept? Is it +1 or -1? Let's go ahead and plug one of these points in to find out. If the slope is 3, and so far we have y equals 3x plus b, let's go ahead and plug in 0, 1 in for x and y. Y is 1, 3 times x, which is 0, plus b. This simplifies into 1 equals 3 times 0, or 0, plus b. In other words, 1 equals b. So b, or our y-intercept, is +1. 3x plus 1 is our function, C. And now for our second question. This one comes from the ACT. This is number 35, so already a little bit further on, kind of difficult. Let's see what's going on. Which of the following is the graph of the equation 2x plus y equals 4 in the standard coordinate plane? What makes this problem difficult is you are not given the line in the format we talked about, which is y equals mx plus b. Instead, you're given it in what's called standard form. But don't despair. We can manipulate this equation to turn it into y equals mx plus b form. All we have to do is take it, 2x plus y equals 4, and solve for y. In other words, isolate y. Let's do that. Let's subtract 2x from both sides. We end up with y equals -2x plus 4. When we compare this to the y equals mx plus b model function, it looks like m, or the slope, is -2, and b, or the y-intercept, is +4. Which of these lines has a slope of -2 and a y-intercept of +4? Well, we know if the slope is negative, it's got to be going downwards. We can cross off D and E. And the good news is we probably don't have to do any counting or figuring out which slope is more steep than the other ones, because now let's look what we have. It looks like option A shows us a y-intercept at +4, B shows us a y-intercept at +2, and C shows us one at -4. The line we want has a negative slope and a y-intercept at +4. The only possible option is option A. Okay, thank you so much for joining me for this short but sweet video about slopes and lines, y-intercepts, XY coordinate planes, and the like. Please join me next time. I'll be doing a full ACT section. Make sure to like this video, subscribe to my channel, and together we will get that perfect score. Thank you guys.